Alrighty, let's do the weird ones. Alright, this is the only slide you will hear me refer to as an oblique asymptote. From here on out, I will call them slants. Just because it's a shorter word and we say it more often than we say obliques. So I'll say slant, alright? If you want to say oblique, that's your business, but you could also say slant with me, alright? Now, an oblique asymptote, also referred to as a slant asymptote, it's a asymptote that is neither horizontal nor vertical.
What?
Amazing. It's a line. See that? It's a line. Crazy, huh? It's a line. That's an asymptote, alright? Now, where they happen at, if you read really carefully, it'll say in there, in that box of key words, if f of x equals a of x over b of x, I'm reading right here, and a of x and b of x are polynomial functions with no common factors other than 1, and b of x does not equal 0, all the same normal lingo of it works, right? Same stuff as always. Now the important stuff. Then the function has an oblique asymptote if the degree of a of x minus the degree of b of x equals 1. So I'm backing up here to this slide. Okay. Remember yesterday when we looked at this bullet? A of x is greater than the degree of b of x, and that's all it said. It's just bigger. It didn't say bigger by how much. It said there's no horizontal asymptote. Okay? But now go back and look at this graph. This graph was x squared over x plus 1. Degree of your numerator? 2. Degree of your denominator? 1. So you see that in that line? You see where that asymptote would lie? See that right there? Make sense? Okay. That's why there's no horizontal one. Because it's crooked. Right. Okay. Now, these only happen when its degree is bigger than 1. If it's bigger than anything else, then you're off into the weird wacko land anyhow. Okay? The equation of that asymptote is going to more than likely be a line, and it's the equation of the actual division a of x divided by b of x with no remainder. Which means what? Actually, no. It means long. So, any questions?
How do you find the oblique asymptote?
You'll see. We'll do it. We're going to do it. Okay? Everybody good? All right, moving on. So, graph. X squared plus 4x plus 4 divided by 2x minus 1.
So for these problems, do we need to find the zeros?
Yes, that's what I'm about to do. All right, it's okay. Step 1, you still want to go find your zeros. All right, so step 1, zeros. That's from your numerator. X squared plus 4x plus 4 factors how? X plus 2 quantity squared equals 0. So you have a 0 at x equals negative 2. Right there. Step 1. Okay. Everybody good with that? I'm gonna shrink it, alright?
Are we still finding the other asymptotes?
Yep.
Yes?
Yep. Step 1, way up there. Okay. Step 2. Your asymptotes. First one, vertical, which is your denominator, equal to 0. Add 1, divide by 2, x equals 1/2. So you have a vertical asymptote. Yeah, these can be ugly. At 1/2. About right there, not drawn to scale.
vertical asymptote?
Mm-hmm. Mitchell. Okay. Everybody good with that work? Because I'm going to shrink it. Make it tiny. All right. Step 3. Now you check your horizontal, okay? So numerator, whoops, gosh, can't do it with the arrow. So your numerator is bigger than your denominator by 1.
Do you have to write that?
No. Which means you're going to have a slant. Okay?
Absolutely.
So should we still write out no horizontal asymptote?
No, you don't need to. If there's a slant, you won't have a horizontal. All right? Everybody good? Now, to get that slant to asymptote, you have to do long division with this. Okay? So x squared plus 4x plus 4 divided by 2x minus 1. Okay? If your factor is linear, you could do it with synthetic. To be quite honest, though, you're going to get a lot of like 2x minus 1s. And if you remember with synthetic, there was a rule that said this had to be what? Anybody remember? That had to be 1. So if that's not 1, then you have to divide that by 2 and divide everything up here by 2. And it's honestly just kind of more of a pain in the butt, and it's easier to just do it with long division, to be quite honest. Okay? So then go through the motions with it. X squared divided by 2x is what? Think about it in your head. X squared over 2x.
X over 2.
X over 2 or
1
1/2 x. Since it's eventually going to be a line, right? So 1/2 x. Now you multiply that 1/2 x into here, and remember you distribute it through, right?
Wait, how did you get 1/2 x?
2x squared divided by 2x. Okay. 1/2 of x times 2x gives you, let me make another red color here. Gives you x squared. 1/2 x times negative 1 gives you negative 1/2 x. And remember what you did next? Switch your signs and then add. Or subtract them, but subtract them both, okay? So x squared minus x squared gives you 0, which is what we need. 4x plus 1/2 gives you 4.5, or I put it as 9/2 x. The plus 4 comes down. Okay, remember that. Now you do 9/2 x divided by 2x. Okay, so the x's cancel, right? Think about it. 9/2 x over 2x. The x's cancel. If you're dividing by 2, you can also think of it as multiplying by what? 1/2. So 9/2 times 1/2 gives you 9 what? 9/4. Okay, 1/2 x plus 9/4, which I know is ugly. Okay, I know that. All right. All right, now you could go through and do 9/4 times 2, 9/4 times negative 1, and get this whole mess. But to be quite honest, you don't care, right? Because that's the equation of your slant asymptote, and we don't care about the remainder. Okay, the remainder is irrelevant here. If there is one, if there isn't one, irrelevant. Okay, you do your synthetic division from here, you get this line. That is the equation of the line of your slant asymptote. Okay. Okay. Now from here, you're kind of in the two. You need to do two things. Okay, because I want to kind of see you do both of these things. You go out. Now we're done. We're done. We're graphing, right? Okay. Once you have that slant asymptote equation, now you graph. Okay. You need to graph two things. You need to graph the equation itself and see what it looks like. The other thing you should probably graph is what? graph your asymptote. Okay? Graph your asymptote along with it. All right? Now I'm going to throw you up here a rough etch-a-sketch of it. Because let's see, I crossed at about 2.25. Something about like that. It's pretty close. And then your graph ends up looking like this. And then like that. Okay, that's what your graph will end up looking like. And then I'll show you guys this in a second. Wait, whenever you plug it into your calculator, then you have it like right next to each other. So you can see, especially you color calculator type people, you guys have it real good because it's like different colors even whenever you graph it. Just remember to always group them together, you know, group your denominator, group your numerator together. Okay, so here's the picture of a graph on your calculators. What I wanted to show you is if you hit second table, all right, and obviously these aren't going to be pretty points, to be quite honest, but there could potentially be some decent points. Like if you look here, like remember what y1 is? y1's my asymptote, y2 is my function, okay? So I know the point 3, 5 on my function. You know the point -2, 0. Other than that, that's about all you got for it. But if you hit, see where it says press plus for delta table? Have I showed you guys this yet? Oh, have I? Okay, maybe it's been a while anyway. If you press plus right now, and it'll say delta table, what delta means is changing. So what do you want your table to change by? And say you want them to change by halves. So you go hit 0.5, you hit enter, and then it gives you the half values of x also. See that? So if you want to get a little accurate with your asymptotes or anything you're ever graphing, you could do that too. So you know that it's at 3.5 and 4. And you can kind of guesstimate your half points, you know. Okay, make sense? Okay, any questions on that? Set your numerator equals 0, which is x squared equals 0. So x equals 0, so you have a 0 at 0. Boom, there it is, the ordinate. Vertical asymptote, I wrote it a little small, it's a little tiny up there, but it should be x equals 2. Okay, which is this vertical line right here. Make sure you put in your zeros for your missing stuff. Okay, x squared, 0x, and 0. Divided by x minus 2 ends up being x plus 2, so that's that red line. And then when you graph it, you have parabola-looking figures here and here.
Oh, what do you do with the zeros?
Oh, what 0?
Like, you know, you find a 0.
Yeah.
What do you do with it?
It's just the starting point right here on your parabola, on that part there.
Oh, okay.
You just find that point and that's it. It just helps you graph a little accurate.
Why would it be negative 2x?
Where you at?
Oh wait, never mind. It's a positive. Okay. And then how can you take out an x when you're technically saying like 1x and you multiply it through this quantity is greater, like the inside quality is greater than because you can subtract it. Like, I don't get how that's.
Okay. Typically, this is the way these will look. I want to show you the next one though. All right. And I'm going to honestly fly through a little bit. So if you need to catch up on the video, please do so. All right, since we don't have a whole lot of time left, and I'm going to get you guys your homework tonight. So for your zeros with this one, you do x cubed minus 1 equals 0, which gives you x cubed equals 0, which gives you x equals 0. Okay, I'm screwing up. X equals 1. Sorry. So x equals 1. There. Okay, great. Now, for your asymptotes, x squared minus 4 equals 0, so x squared equals 4, so x equals negative 2, and plus or minus 2. So we should have asymptotes, vertical ones, at x equals positive 2 right there, and x equals -2 right there. See that? Okay. Now, the weird part here is your slants. And it's weird in multiple ways. First way it's weird is look what you're starting with. X cubed divided by x squared. Okay? First time you've seen it, to my knowledge. Okay, so x cubed, you still put in all your zeros for it. Minus 0x squared, minus 0x, minus 1. I'm going to need more room than just that.
You have to make those minus 0x?
They can be pluses, it doesn't matter. Over, or divided by x squared minus 4. Okay, watch what happens. You start it the same way, okay? X cubed divided by x squared gives you what? X. Okay? X times x squared gives you x to the third, which is going to cancel this out. What's x times -4? -4x, okay? Now, since that's the case, and you have 0x squareds, the next time you go try to divide -4x, or what will end up being positive 4x, by x squared, what will you have? What will that end up being? If you try to do 4x divided by x squared, it's what? Here, hold on. I'll get you. Hold on.
Wouldn't it be negative 0x squared?
What's 0x squared? 0. So your next divisions in...
Excuse interruption. Boys baseball is not to be dismissed until 2:30 today. Thank you.
Great. Your next division is going to be 4x. So what's 4x over x squared that you get from over here? 4 over x, which starts your what? Starts with an R. Remainder. Okay? Starts your remainder. So your slant asymptote is just x. The line y equals x, which goes through the origin. Okay? Which you wouldn't think would be a huge deal. Okay? Remember I said this was weird in 2 places. Alright? I'm going to delete all this. Everybody good? The top line is the function. Line 2 is my asymptote. Watch the graph. Remember what this is. This is your asymptote, right? Okay, I'm getting there. Okay? I am getting there. Shh. Everybody relax. Don't throw out all the knowledge you've known yet. Everybody shh, quiet. It's fine. Okay? It's a hole. All right? Because okay? Calm down. You guys will be okay. All right? I promise you. Listen, shh, guys, quiet though, seriously. There is a hole in the graph, all right? It is very rare, okay, especially for your purposes. It's going to be rare, but it does happen. Actually, there's point discontinuity in this section. I don't talk about it. It's fairly simple, though, so if you want to look at it, look at it. If it's the way it's supposed to be, just do it, okay? It won't happen often, okay?